Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery, and no, Anna, I still haven't slept, except now it's not the eclipse's fault, it's the meteor shower's fault.
The Perseids really picked a big week to peak.
It's Friday, August 14th, Series 5, Episode 167. So after yesterday's total solar eclipse special, you'd think the sky would take a night off. It did not.
It really didn't. Today's main story is a big one for anyone who was fascinated by yesterday's black hole story. Astronomers using James Webb have found what they're calling a black hole star, and it might solve a 50-year-old mystery about how supermassive black holes get so big so fast.
Which incredible timing, because yesterday we told you about 3 supermassive black holes sharing one galaxy. Today's story is basically here's how black holes like that get so massive in the first place.
Then we've got 3 more. The Perseid meteor shower's spectacular peak overnight, a new satellite designed to keep watch over what other countries are doing in geostationary orbit, and a very well-earned retirement. Veteran astronaut Mike Fincke is hanging up his flight suit after 30 years at NASA.
Lots to get through. Let's get into it.
Okay, so first, what even is a black hole star? Because that sounds like a contradiction.
It kind of is, and that's the point. Picture a young, rapidly growing black hole, but instead of the thin, tidy accretion disk you usually picture, it's wrapped in this incredibly dense, turbulent gas cocoon of gas. So dense that the whole thing glows and radiates almost like a star would, even though the engine at the center is a black hole.
So it's a black hole in a gas trench coat.
Basically, yes. And because that gas envelope is so puffed up, the object appears absolutely enormous, over 100,000 times the size of the sun in terms of the light-emitting region, even though the black hole itself and its usual accretion disk would normally be tiny by comparison.
And this particular one has a name.
Mom BH Star 1. Mom standing for the Mirage or Miracle JWST survey came out of, which is a great name for a survey, honestly. The light we're seeing left this object about 660 million years after the Big Bang. That's roughly 13 billion years ago, which makes it the earliest confirmed black hole star found so far.
So we're really at the edge of what Webb can see.
Right at the edge. This is cosmic dawn territory. The team is led by Rohan Naidu at the University of Hawaii's Institute for Astronomy, working with Jorryt Matthee at the Institute of Science and Technology, Austria. And what tipped them off was something called a Balmer break, a specific spectral signature usually associated with stars showing up alongside signs of a genuinely supermassive black hole.
Which shouldn't really go together.
Exactly. That combination is what makes this object so weird and so interesting. It's got a stellar-looking spectral fingerprint, but the mass and energy output scream black hole.
Okay, so why does this matter beyond just cool, a new weird object? What mystery does it actually help solve?
So here's the 50-year-old problem. We know there are supermassive black holes, billions of times the size of the sun, sitting in galaxies from a remarkably early in the universe's history. The issue is there hasn't been anywhere near enough time for a black hole to grow that big just by slowly swallowing gas at the normal rate. It's like finding a fully grown oak tree 3 weeks after you planted the acorn.
Right, we talked about a version of this exact puzzle yesterday with those 3 black holes in one galaxy.
Exactly the same puzzle, and this black hole star might be a missing piece. A black hole caught in the act of growing at a wildly accelerated rate, hidden inside this dense gas envelope, which is actually feeding it far faster than a normal thin disk could.
So it's not just growing, it's basically bulking up and fast forward?
That's the idea, and there's an even bigger connection here. You might have heard of little red dots, these mysterious compact red objects Webb started finding all over the sky back in 2024. Nobody could quite explain why they were so red, so common in the early universe, and then basically absent today.
I remember these being a genuine head-scratcher.
Total head-scratcher. And the leading theory now is that little red dots and black hole stars might be the same phenomenon. A black hole wrapped in a hot, ionized gas cocoon that glows almost star-like while it grows, then fades from view once it's eaten through its envelope. So this one object, Mom BH Star 1, could be the best example yet of the engine that's been powering hundreds of these little red dots.
That's a big claim for one object.
It is, and to be fair to the skeptics in the room, the Mirage, half of Mirage or Miracle, is doing some work in that title. This is still a hotly debated interpretation. The whole result rests on reading a fairly subtle spectral signature correctly. And this kind of thing has been published as a preprint and argued over for more than a year before this. Not everyone agrees black hole stars are definitely the answer to the little red dot puzzle yet.
So, healthy skepticism, but a genuinely exciting candidate.
Right. And Matthee actually leaned into that tension directly. His quote was, "Far from a mirage, this might well be a cosmic miracle."
I love an astronomer with a sense of drama.
Naidu's take was a bit more measured, but still pretty thrilled. He said something like, "We're getting really close to figuring out how these black hole stars form." His current best guess is that they might start from mergers of supermassive stars. Stars weighing tens of thousands of suns inside dense globular star clusters in the early universe, built up through repeated stellar collisions.
So, giant stars collide and merge, eventually collapse toward a black hole, and the whole mess is still wrapped in gas as it does it. So, it glows like this hybrid black hole star thing.
That's the working model, and it would also explain some genuinely weird properties astronomers have noticed in old globular clusters closer to home, like unusual chemical patterns that have never quite made sense.
Though this one distant 13-billion-year-old object might help explain both how the biggest black holes in the universe got so big and some local mysteries sitting in our own galactic backyard.
That's the hope. Webb's going to keep hunting for more of these. Mom BH Star 1 being the earliest confirmed one just means it's the current record holder, not the last one we'll find.
Which, tying it back to yesterday, if black hole stars like this really are the growth hack behind those triple black hole systems we talked about, that's two huge stories in 2 days that are actually two chapters of the same bigger picture.
The early universe was apparently just an absolute black hole buffet.
A fitting way to put it. Great segment to follow yesterday's.
Okay, story 2, and this is the one that's actually responsible for my sleep deprivation. The Perseid meteor shower peaked overnight between August 12th and 13th, just hours after yesterday's total solar eclipse wrapped up.
An eclipse and a meteor shower peak within about a day of each other? That's a genuinely rare double bill.
It really is, and the conditions could not have been better. This happened right around the August new moon, so skies were nice and dark, no moonlight washing out the fainter meteors. Observers in good locations were reporting hundreds of shooting stars visible to the naked eye across the peak night.
Remind people what they're actually looking at when they see a Perseid.
So the Perseids are debris from comet 109P Swift-Tuttle, mostly tiny dust and sand-sized particles that Earth plows through every year around this time. They're traveling at about 37 miles a second when they hit the atmosphere, which is why they burn up in these bright, fast streaks.
Small pieces of comet dust dying dramatically. Very poetic.
Genuinely is, and the astrophotography from this year's peak has been stunning. I saw shots combining Perseid streaks with the Milky Way, the Andromeda Galaxy, and the Pleiades cluster all in the same frame. Photographers were out shooting from Iran, Israel, Texas, Spain, Turkey, China, genuinely a global event.
One photographer's quote stuck with me, something like, "I've got the Pleiades, Andromeda Galaxy, and Milky Way with the Perseids," basically describing an entire deep sky greatest hits tour in one photo.
Exactly that kind of night. And if you miss the exact peak, don't panic. Swift-Tuttle's debris trail stays active through about August 24th, so you'll still catch meteors most nights this week, just at a lower rate than peak.
So there's still time to get outside, find some dark sky, and give your eyes 20 minutes or so to adjust.
No telescope needed for this one either. Binoculars and telescopes are actually the wrong tool. Just your eyes and a wide patch of sky.
After the eclipse and now this has genuinely been one of the best weeks of the year to just look up.
Best week of the year, no notes.
Story 3 is a change of pace. This one's about keeping an eye on things a little closer to Earth, in geostationary orbit. San Francisco-based Astronomers announced a new line of spacecraft yesterday called Perceptor, and its whole job is to monitor what other satellites are doing up there.
So basically a satellite whose job is to watch other satellites.
Pretty much. Geostationary orbit sits about 22,236 miles up, and it's genuinely valuable real estate. That's where a lot of communications, military, and early warning satellites live, because at that altitude, a satellite orbits in sync with Earth's rotation and basically hovers over the same spot.
Which also makes it a spot worth watching closely.
Exactly, and that's the pitch here. Perceptor is built on Astronomers' existing micro-geo satellite platform, so it's smaller than a typical GEO spacecraft, and it's loaded with sensors to assess other satellites and the environment around them. It uses electric propulsion, which means it can reposition itself dozens of times over its mission life, doing multi-angle flybys to actually inspect other satellites up close.
Inspect in what sense, though? Friendly satellites, hostile ones, both?
Both, honestly. The company's framing it partly as a diagnostic tool, flying past a friendly satellite to help troubleshoot an anomaly it's having, and partly as a security tool for keeping tabs on what other nations' satellites are up to nearby.
And I'm guessing that second part is the real driver here.
It's definitely front and center in how they're pitching it. Astronomers CEO John Gedmark put it pretty bluntly. There are blind spots that will be used against us if not eliminated. And the announcement specifically points to a couple of past incidents: a Russian spacecraft that approached within about 100 miles of an American spy satellite back in 2020, and reports of Chinese reconnaissance activity near suspected U.S. Space Force satellites in 2023.
So this is very much a response to other countries are already doing this kind of close approach, and we've had limited visibility into it.
That's the argument. Astronomers already operates 5 satellites in GEO supporting U.S. military operations, remote connectivity, and GPS-related capabilities. So this isn't a totally new business for them. It's an extension into space domain awareness specifically.
No launch date yet, I take it?
No firm date announced yet, but worth watching because if Perceptor works as advertised, it's a pretty significant shift in how much visibility commercial operators, not just government agencies, will have into what's happening in that orbital neighborhood.
Satellites watching satellites watching satellites. The future is a bit like a hall of mirrors.
A very expensive hall of mirrors 22,000 miles up.
Last story today, and it's a nice one to close on. Mike Fincke, one of NASA's most experienced astronauts, has retired after exactly 30 years with the agency.
30 years is a serious career.
It really is. Fincke is a retired Air Force colonel who was selected as an astronaut back in 1996 as part of the astronaut class nicknamed the Sardines. Over his career, he became one of only 13 people ever to have flown to orbit on 3 different types of spacecraft. And by the end, he'd actually flown on 4 separate vehicles across 4 missions. Twice on Soyuz, once on SpaceX Shuttle Endeavour, and once on SpaceX's Crew Dragon Endeavour.
That spans basically the entire modern era of human spaceflight: shuttle, Soyuz, and commercial crew.
It really does. He commanded the International Space Station twice across 2 different expeditions more than 15 years apart. Expedition 18 back in 2008-2009, and then Expedition 74 just this past December and January. He also spent time as chief of the Astronaut Office's Commercial Crew Branch and worked on developing the Starliner program.
And his most recent mission was Crew 11, right?
Right. Launched in August of last year alongside Zena Cardman, JAXA's Kimia Yui, and Roscosmos cosmonaut Oleg Platonov. And that mission actually ended early. In January this year, Fincke had a genuinely scary medical incident. On board, he described suddenly losing the ability to speak for about 20 minutes during dinner.
That's frightening, especially in orbit.
Genuinely frightening. He said it came on completely out of the blue. NASA brought him home early as a precaution, which is obviously exactly the right call.
Good that he's all right, and good that this send-off is on his own terms.
Definitely. In his farewell statement, Fincke said, "After exactly 30 years, I am departing NASA, but I remain deeply committed to, among other things, helping prepare the next generation of explorers.
Which feels like the right note for someone who's flown Shuttle, Soyuz, and Commercial Dragon to go out on, a career that's basically a bridge between eras of spaceflight, handing things off to whoever flies next.
A genuinely well-earned retirement. Thank you for your service, Colonel Fincke.
Okay, that's our stories for today. Quick recap. James Webb may have found the missing link in how supermassive black holes grow so fast in the early universe. A gas-shrouded black hole star called Mom BH Star 1, glowing from just 660 million years after the Big Bang. The Perseid meteor shower delivered a spectacular peak overnight, right on the heels of yesterday's eclipse. Astronomers unveiled Perceptor, a new satellite built to keep watch over geostationary orbit, and veteran astronaut Mike Fincke retired from NASA after 30 remarkable years and 4 different spacecraft.
If you enjoyed today's episode, the best thing you can do for us is leave a rating or review wherever you're listening and share the episode with a fellow space nerd. You can find full show notes, sources, and links for every story we cover today at astronomydaily.io. And find us on social media. We're at AstroDailyPod pretty much everywhere.
We'll be back tomorrow with the weekend wrap. Until then, keep looking up.
Clear skies, everyone.